Okay, this is the hardest level. Don't be frustrated if you can't get it. I'll still give you credit for trying. But now we're going to do the reverse. So factoring when we already have a trinomial, we're trying to get it into two binomials. So doing the opposite of what you were just doing. So I know my 3x squared goes in this box. I know my negative 4 goes in this box. And I know that these two boxes add up to 11x. So what's crazy is you're going to do a times c as a shortcut. Oh, we're going to label these. I forgot to say that. Sorry. The format of a quadratic is ax squared plus bx plus c. So whatever's with the x squared is a, whatever's with the x is b, and whatever's the constant is c. So my a times c would be 3 times negative 4, which is negative 12. That's like my magic number. I'm looking for two numbers that add, that are factors. Okay, shoot. That multiply to negative 12 and add to positive 11, which is my B term. Like literally back when I did this in middle school, we just did this in our head. Like we just stared at it and tried to find what went in these two. I don't know how to teach that way. If you can do these in your head, heck yes. I just know how to do them in my head. I don't know how to explain it. So this is the shortcut, is that you find your a times c and are looking for two numbers that multiply to negative 12 and add to positive 11. So I'm going to start listing off. I usually do it up here. So I have negative 12, and I'm just going to list off as many factors that I can think of. So negatives are tricky because we get negative 2 times 6, but also 6 times, positive 2 times negative 6. Okay, negative 2 times 6, negative 2 plus 6 is positive 4, which is not 11. And then 2 plus negative 6 is negative 4, which is also not 11. So I know it's not right. Negative 3 times 4, positive 3 times negative 4. Negative 3 plus 4 is 1, which is not 11. And then 3 times negative 4. 3 plus negative 4 is negative 1. So also not 11. Remember, I'm looking for 11 because it's my B term. I'm thinking. The last factors I can think of are 1 times negative 12 and negative 1 times positive 12. Well, negative 12 plus 1 is negative 11, which is close but not right. And 12 minus 1 is 11. So ding, ding, ding. This is our numbers. I like this step because it's kind of like a puzzle. Again, you're just doing mental math, or you can use your calculator if you need, but you're trying to figure out those two numbers that are going to multiply to be AC and add to 11. So I'm going to put them into my box as negative 1x and positive 12x. So this is what my box looked like. We're literally just reverse engineering our process. I'm going to write in purple because I liked that color. So I need numbers here and numbers here. And we're going to literally pull. I wonder if I should use a different color. I probably will. Okay, so I'm going to start with this box. Now we're factoring, just like we did before, this whole row. So 3 and negative 1 don't have anything in common except for the number 1. So a 1 comes out. But they both have an x. So an x also comes out. Let's do this pretty blue next. Okay, I'm going to find this by factoring this row, finding the greatest common factor. 12 and 4 both have a 4 in common. However, only this term has an x, so there's no x as a common factor. Next, I'm going to do this line by factoring, out my column. 3 and 12 both have a 3 in common, and they both have an x. So we can factor out an x. And then let's do green right here. -1 and -4 both have a -1 in common. And they don't have an x in common. So my final answer would be 3x minus 1. Sorry, that's my alarm. Times 1x plus 4. One way to check would be on Desmos. I can also just check like this box. 3 times 1 is 3. X times x is x squared. This box, 1 times -1 is -1. There's an x. 3 times 4 is 12. There's an x. And then -1 times 4 is -4. So I literally went backwards from what we were doing before. Again, this is really tricky. This is the hardest thing we will do all year. So if you can get this, our last few units, like this is literally the hardest part of algebra, in my opinion. But these two are equivalent. You could type them into Desmos, you get the exact same answer. Don't be stressed out. We're going to do it again. We're going to label my A, my B, my C. We're going to put it in to our box method. 2x squared goes in the first box. 15 goes down here. This is, oh no. This is our mystery 2 numbers, but I know they will add to B, which is -13. Now over here, I'm going to do A times C, which is 2 times 15. Oops, I don't know where that little negative sign came from. Which is 30. So I'm looking for 2 numbers that multiply to 30 and add to -13. So I'll make my little tree of 30. This is easier because it's positive. So I could do 6 times 5 or -6 times -5. This equals 11. This equals -11. We could do 15 times 2 and -15 times -2. 17 is not it. -17 is not it. Oh, we could do 10 times 3. -10 times -3. 10 plus 3 is 13, which is not it, but close. And then -10 plus -3 is -13, which means we have a winner. It doesn't matter where you put them, just make sure you put an X on them because they are X terms. And then we're going to go spot by spot. So I'm going to look at my row. 2 and -10 both have a 2. That's their common factor. And then they both have an X. -3 and 5 both have -3 and 15 both have a 3. However, they don't have an X in common. 2 and -3 only have a 1 in common and an X. And then let's do -10 and 5. They both have a 5, but no X. So this is where I'm going to check my work because there might need to be some negatives. So even for me, I have to think about it. So let's pick a different color so you can see what I'm doing. Let's do dark purple. So I'm looking at my 2x squared and confirming that 2x times 1x is 2x squared. My -10x, 2 times 5 is +10. So I'm just going to put a negative on that guy. Over here, I have -3x, but I have 1x times 3, so I'm also going to make this term negative. And then 15 from -5 times -3 is correct. So a lot of times if you're stuck, just double check on the negative, because that might be what's throwing you off. And these two binomials are equivalent to this trinomial. You can type it in decimals and you'll see the exact same quadratic. Okay, try it on your own, but you can pause the video and try it on your own. You can unpause it if you get stuck or if you just want to check your work. So A will always go here, C will always go here, and B is my special number that I know adds to -5, which is my B. I'm going to come over here and do A times C, which is 2 times -7, which is -14. I'm looking for two numbers. They're going to multiply to -14, and they're going to add to -5. I'm going to make my little factor tree to think about things. We can start with 1 times -14 and -1 times +14. If I add 1 and -14, I get -13, which is not what we're looking for. -1 plus 14 is +13, also not what we're looking for. 2 times -7 and -2 times +7. 2 plus -7 is -5. So that's our winner. It doesn't matter which box you put them in as long as they both have an X. And then let's factor. 2x squared and 2x. They both have a 2. And then they both have an X. Over here, these guys both have a -7, but no X in common. These guys, 2 and -7, only have a 1 in common and an X. And these guys only have a 1 in common and no X. I am going to double check so quick because I love checking my work. 1 times 2 is 2. X times X is 2 with 1X. 1 times -7 is -7 with 1X, and 1 times -7 is -7. I can also, once I have my two binomials, I can check that on decimals. Just type them both in. They should create two quadratics that are perfectly equivalent. Don't be stressed about this one. Again, it's the most challenging. Give it a shot. If you can't figure it out, I'll still give you credit for trying. Just show your work. Good luck.